We're going to talk about some describing functions. Now, you did a lot of investigating functions through Algebra 1 and Algebra 2. Here are some pieces that we left out. And we're going to talk about these in the pre-calc sense. Do understand, though, that there are some ideas and concepts from calculus that are sometimes, will help clear these up a little bit. So here's the definitions we're going to use for now. Again, they're not really the best definitions, but they will help you better understand this. Take a moment, copy them down. Now, how do we determine if a function is even, odd, or neither? And basically what that means is an even function, any x value would equal any negative x value. The easiest way to test this would be to plug in a positive and negative of the same number. So let's just say I tested f of 2, and that should equal f of negative 2. So I'm going to plug 2 into my equation. And then I'm going to plug negative 2 into the same equation. If I get the same answer, they're even. If I get opposite answers, they're odd. And if the two numbers just aren't related at all, then that would be an example of neither. So 8 minus 5 is 3. And negative 8 minus 5 is negative 13. These two numbers are not equal. They are not opposites. Therefore, this function is neither even nor odd. Next example. You don't have to pick 2 and negative 2. You could pick 21 and negative 21. Trying to keep it easy. You could pick 1 and negative 1. So if I plug 1 in for x, all right, and then I plug negative 1 in for x, and I solve each of those. 1 cubed is 1, minus 1 is 0, minus 2 is negative 2. Negative 1 cubed is negative 1, plus a negative 1 means adding a 1 to that. So that's 0 minus 2 is minus 2. Therefore, even. Negative 2 and negative 2 are the same number, so that function is even. Next, I have h of x. So if I plug a 1 and a negative 1 in here, so 1 squared minus 6, negative 1 squared minus 6, I get negative 5 and negative 5. Therefore, this function again is even because those two numbers are equal to each other. And the last example I have here, k of x, again, you could pick 1 and negative 1 again, 2 and negative 2, any numbers you want as long as they're opposites. So 1 to the 4th minus 1 squared minus 4, negative 1 to the 4th minus negative 1 squared minus 4, and again 1 minus 1 is 0. So negative 4, 1 minus 1 is 0, negative 4. Another example of an even function. If the numbers are equal, they're even. If these numbers would be opposite, like negative 4 and positive 4, then it would be an odd function. If the two numbers are not related at all, then it's neither. Let's take a look at what the graphs look like. So on a graph, if I'm determining whether they're even, odd, or neither, I'm looking at similar values. So here I look at 2, okay, and negative 2. Look at the y values for 2 and negative 2. I get the same y value for both of them. That makes this function even. Here, if I look at my y value for 1 and my y value for negative 1, you'll see that I get the same y value. It's just one's positive and one's negative. Therefore, this is an example of an odd function. Same x value, 1 and negative 1, but here I get a positive 1 for my y. Here I get a negative 1 for my y. That makes them odd because those numbers are opposite. Example like this, if I go over to 2, okay, and you notice here my y value is, say, a half. I go to negative 2, my y value is negative a half. Positive a half, negative a half are opposites. This function is odd. Last, again, spot check here. My 1, I get 2. My negative 1, I get not 2 or not negative 2, I get a half or so. So these numbers are not the same and they are not opposites, therefore this function is neither. So we knew how to tell even, odd, neither from substitution, even, odd, neither from graphing. Let's talk about increasing and decreasing. Okay, definition: increasing, decreasing. The function is increasing when its slope is positive, it's decreasing when the slope is negative. Now keep in mind these are curved lines, therefore they don't have any consistent slope, right? But we're looking at their average rate of change. All right, so when I look at this, technically speaking, in calculus, you'll be talking about the slope of the derivative, okay, at a particular point. Here, when I look at this, I'm just basically asking myself, is this climbing uphill? If it is, how far? So it looks like to there, which is negative 2. So my increasing interval would go from negative infinity to negative 2. At negative 2, it's no longer increasing or decreasing. Okay, it would have a slope of 0. The tangent line would have a slope of 0. But after negative 2, it begins to decrease. Excuse me. This needs to be a parenthesis. After negative 2, it begins to decrease. It decreases all the way to positive 2. So decreasing interval, okay, goes from negative 2 to positive 2. After positive 2, you see how the line begins to climb again. It begins to go up again. Therefore, I would be increasing again from 2 to infinity. And it's going to go up forever. Okay. These special points in between, when we're describing increasing and decreasing, these are called maxes and mins. A max and a min, you already talked about those in Algebra 1 and Algebra 2. Not too difficult here. Writing the intervals might be. Last, concavity. Describe the intervals for which the graph is concave up or concave down. And the easiest way here is, will it hold water or will water pour out over it? Okay, if it holds water, it's concave up. If it doesn't, it's concave down. So when I look at this example in particular, if I poured water into it, I would say this graph is concave up from 0 to infinity. This would hold water. This right here would hold water. So concave up would go from 0 to infinity for my interval. And concave down then, okay, if I poured water on this, the water would pour out over. That means it's concave down. And again, that's not, the book definition here, right? That's sort of like the dummy definition. And it's concave down from negative infinity to 0. So there's some of your new descriptors. Let's take a look at one last example here. Okay, here's a graph that has a couple things going on. All right. So is it even, odd, or neither? If I'm looking at, say, the x value of 2, I'm getting what looks to be something around negative 60. The x value of negative 2, it looks to be 0. Those two numbers are not equal and they are not opposites. Therefore, I say neither. What intervals is the graph increasing? It appears to be increasing. Okay, this right here all the way to, let's say, boy, that stinks. Mr. Warner, you could have picked a better example. Right there. So let's say it's increasing from negative infinity to negative 4. It's increasing again from positive 2 to infinity. I would say that the graph is decreasing from negative 4 to positive 2. It has a downward trend. Down, down, down. Okay, again, without talking about tangent lines, because we haven't learned that yet, we're going to have to use the visual aid here. Negative 4 to 2. And then we have concavity. So where does it hold water? Where does water pour out? Now finding the inflection point exactly here, this is a little tricky because we haven't learned about derivatives yet. Okay, but let's just say that, inflection point's right here. I'm going to call that negative a half. Actually, it might be a little farther up there. We could just say -1 for what we're doing this for. So right there's your inflection point. So this is concave up because it holds water. This is concave down because water pours out. So I would say concave up, and I'm calling it -1 to infinity. Concave down, and we're going to call that -infinity to -1. We'll do more examples in class. Hopefully you wrote some of that down and are prepared for some questions if you have any.